Proxima Centauri is in the southern sky, but you can't see it with your bare eyes. It's a small, cool star, and it's much fainter than what you can see, although it's the next closest star to us. So there was a very interesting, very exciting discovery about Proxima Centauri recently. Astronomers discovered an Earth mass planet in the habitable zone of Proxima Centauri. Now, the habitable zone is the distance from the star where liquid water can exist on the planet, and therefore possibly life. Proxima Centauri is a red dwarf star. It's cooler than the sun. Therefore, you have to be a lot closer to the star for the same temperature as we are now from our sun. So it turns out that the habitable zone is about 20 times closer to Proxima Centauri than the Earth is from our sun. The radiation from the flares and coronal mass ejection is 400 times larger than coronal mass ejections and flares on the Earth. So Proxima Centauri is a star that we've studied for its flares. We've observed this star with the telescope in the southern hemisphere over 3 nights, and I'm showing you data from this project of the star Proxima Centauri in the near ultraviolet. All the spikes in this data here are the flares, and the biggest flare increased the star's brightness by a factor of 5, something the sun does not do. So what you can see that the star is flaring almost all the time. And so if you were around this star on the planet in the habitable zone, it would be a very dramatic light show. So it's an open question of whether there are coronal mass ejections associated with all of these flares. So we can't detect coronal mass ejections around other stars, at least not yet. We would like to know if there is a dramatic effect on the planet surrounding Proxima Centauri from all these flares and all the material that's blown off from the star during these flares. Hopefully we will go to our nearest star one day, and we would like to know if the planet in the habitable zone has an atmosphere like the Earth, and if we can live there, or if it's such a violent place that the flares and the coronal mass ejections have blown off the atmosphere entirely. So we use the sun to try to say something about the coronal mass ejections on other stars, and we use flares as a common thread. And the secret to the flares are the magnetic fields, which are very complex, and we need very, very high detail images of the sun to understand these magnetic fields.